Okay, hello everybody and welcome to another tutorial. My name is John Lucky and today we are going to have a look at Cisco. We are going to create an IPsec VPN connection between our between our headquarters in Brazil to our branch in France. This is our topology. Let's assume that this is the internet, and let's assume that these IP addresses are public IP addresses. Now, before you start the IPsec VPN configuration, you must always make sure that you can actually reach the other side. You can, your headquarters router should be able to ping the branch router, and the branch router should be able to ping the headquarters router. Otherwise, you will not be able to establish the connection. Now, this is our topology. It's all virtual, by the way. I'm using GNS3, and after we configure the tunnel, we will ping from this PC to this PC, and we'll have a look at the packets being encrypted and decrypted. So the only thing I did here is I just apply the IP addresses to the interfaces. So here is a topology. Take a snapshot if you want to keep an eye on what I'm doing. And there are 6 steps we have to do on each router. The first one is to create an access list, which tells this router, I want to allow this network to be able to reach this network through the tunnel. Then we have to create a crypto policy. Then we have to create a crypto key, the crypto transfer set, and the crypto map. Then after that, we have to apply the map to the external interface. I am going to start with the headquarters, and so let me bring up my PuTTY. So this is my PC1, this is the PC here, and I'm going to ping my default gateway, which is 192.168.1.2. Okay, as you can see, I can reach that, and let me ping the external IP address, which is 10.1.1.1. I can reach that. I wouldn't be able to reach from this PC to the external IP address of the branch router. So let me repeat that, and you'll see that I cannot reach. Okay, it's the same the other way around. I should be able to ping from this PC to my default gateway, and from this PC to the external IP address, but I cannot go any further than that. Okay, so let's go to the headquarters and let's start the configuration. The first thing we have to do is create the access list. I always create extended access lists because I can give them either a number or a name. I usually give them a name because I need to remember, or when I look at them, I need to see the name and understand what that access list is all about, because as you know, you can create many access lists. So IP access list extended, I can give it a number between 100 and 199, or I can give it a name, and I'm going to call it VPN_traffic. So I'll know this access list is got to do with my VPN traffic, and we're going to permit IP from the 192.168.1.0 network. Now we have to give it a wildcard mask. A wildcard mask is the opposite of the network mask. So if our network mask is /24, it should be 255.255.255.0. Now this wildcard mask should be the other way around. Where it's 255 should be a 0, and where it has 0 it should be a 255. So let me go back, and that's how it should be. Now if our network mask was 255.255.128.0, then the wildcard mask should have been 0. That will replace the 255 here. Then another 0 to replace that 255.0, and the next number should be 255 take away 128. right? So I'm just trying to figure out what that would be. That would be 228 and 27. So it's 127, right? .127.255. Okay, I hope this is understandable. That would have been the wildcard mask. 128 and 125 is 255. Okay. So in our case, it's 255, 255, 2550, and that should be 0.0.0.255, and the same with the other site, which is the 172.16. So we'll allow in the 192.168.1.0 network from this site, from our headquarters, to be able to reach the branch, which is the 172.16.1.0, and our wildcard mask is the same again. Okay. That is our access list. We'll access that, exit that. Now we have to create a crypto ISACAM policy. And you can give it a number from 1, 2, 3, whatever. I'll give it a number 10. And we have to authenticate using a pre-share key. In this case, because we don't have a certificate. If your company has a certificate, it's best to use certificates because they are more secure. So we're going to have to create a pre-share key later on. The encryption will be, encryption should be AES, and it has to be, I mean, the default is 128. So the higher the key number, the better, the more encrypted it is. So I'm going to give it a 256 here. Okay. The Diffie-Hellman group will be group number 5. There are many groups there. I'm just going to give it a 5 here. The higher the group, the more secure. And our hash should be SHA. Yes, this is by default, this is what it is, and when later on when we look at it, you'll see that this hash will not be under our configuration because it's there by default. Okay, that's our policy. This is part of phase 1. When you establish a tunnel, there are 2 phases, phase 1 and phase 2. ISACAM is phase 1 and IPsec is phase 2. So what the policy does is telling this router, I want you to communicate with the other router and establish a connection, or a first tunnel, communicate between the two of you and decide how you're going to build a tunnel. Basically, you have to authenticate by using a pre-share key, the same encryption and so forth. Once that has been established, then we will establish the IPsec tunnel where all the traffic will go through. So the first tunnel is just the communication between the 2 routers, and the second phase, phase 2, the IPsec tunnel, is where the traffic will go through that tunnel. So let's go back. I'm going to try and explain things as simply as I can, because I remember when I was studying, I was so confused on some tutorials I was looking at. So we have created the access list and the policy. We'll exit here. Now we have to create the key. Remember, we have to, the 2 routers have to communicate using a pre-share key, and the key has to be the same on both sides. Okay, so we're going to do crypto ISACAM key. I'm going to call, my key will be key 1, 2, 3. In reproduction, this key has to be very, very unique. It has to be numbers, letters, symbols, or whatever. Make it as difficult as possible. Make sure whatever the key is, it doesn't exist in a dictionary. Okay, so and then we do address. That's the peer. The peer is our branch, which is, this is the peer's address. 10.1.1.2. That is our key. Now we have to create a transform set. So we create crypto IPsec transform set, and the transform set name will be set 123. I'm just doing this so it's easy for me to remember, guys. This is just a virtual environment. As I have said, this should be a unique numbers or names, and as long as you can. I mean, 8 to 12 numbers should be great. And if we do a question mark, we'll do the ESP cipher. Okay, it could be 128 is a default number. We can give it a 256 here as well, a high number, and then we'll finish with the ESP SHA-H mark. Remember, it has to be the same on the other side as well, otherwise it won't work. And when we do this, we're going to do some troubleshooting, because as I have said before, to become a good engineer, you should be able to troubleshoot. So when there's a problem, you need to know what to look at and how to go about troubleshooting. And we will do some troubleshooting. And also, if you notice that when I'm here at the execution prompt and type C, I just entered to the I enter the configuration prompt. Instead of me typing config T, I just do C and I enter. This is something that I will show you at the end. I just created some aliases to make my life a lot easier. So if I want to exit now, I don't have to type N, I just type E and that's it, and C, and I'm back in again. Alright, that's something to talk about a little bit later. We done our transform set. Now we have to create our map, crypto map. We'll call it map 123. This is our first map, because we could have we can create a lot more maps, and this will be an IPsec ISACAM. Okay, now we need to set up here, which is the 10.1.1.2, the other side. We have to set the transform set, which is set 123, and then we have to match the access list we've created earlier, which is match the address, if I remember well, is VPN_traffic. Okay, that's all. We need to go under the interface now, the external interface, and apply the map. So interface FA 0/1, we do crypto map MAP123. Okay, this is one site being set. We need to go to the branch and do exactly the same. Show run section crypto. We might come back to have a look at all these settings. And okay, I haven't created any aliases on this router, so I am going to do that a bit later to show you guys. Okay, we need to create the access list, IP access list extended. We'll call it VPN_traffic again, and we'll permit IP from the 172.16.1.0 to the 192.168.1.0 network. Okay, that's our access list. That's out of the way. We'll create now the crypto ISACAM policy. Again, I'm going to give it number 10. We need to authenticate using pre-share key. The encryption will be AES 256, if I remember well. The Diffie-Hellman group will be 5, and the hash will be SHA. Okay, exactly the same as on the other side. The only difference is that the peer's IP address, obviously it will not be ourselves, it will be the other side. We've done that. We need to create now the key, crypto ISACAM key 123. Okay, the PS address is 10.1.1.1. That's our headquarters external IP address. Okay, and then we have to create now the transform set, crypto IPsec transform set. We call it set 123 question mark. We use ESP 256 if you remember, and then we use the ESP SHA-H mark. Okay, that's our transform set. Let's exit here. Now we create our crypto map. Crypto map 123. This is our first crypto map, and it's IPsec ISACAM. We need to set the peer, which is 10.1.1.1. We need to set the transform set, which is set 123, and we have to match our access list, which is match address VPN underscore traffic. Okay, and that's it. We have to apply the map to the interface now, and we should be establishing the connection. Our interface is FA01, so interface fast Ethernet 0/1, and we do a crypto map, and it's map 123. Let's save our configuration. Always save your configuration constantly, otherwise if things go wrong you could lose it. WR, it means write mem, or write running config to, or running config, yes, write running configuration. Okay, so now let's have a look if we have established the ISACAM or phase 1 connection. Show crypto ISACAM SA. There's no association there. Okay, let me generate some traffic. Let's go to PC1 and try and ping PC2 172.16.1.1 unreachable. Okay, now this is where I'm telling you about troubleshooting. If we look at our association again, there's no association there. Okay, we need to create some traffic for the association to established, or the tunnel to be established. So what this is telling us, unreachable. So basically if we go to the headquarters router and we do a debug IP ICMP, okay, and then we ping again the other side, unreachable. So the pings are getting here. So basically this PC is pinging all the way across to this guy, but this guy is replying back to the PC and saying to the PC that destination is unreachable. Okay, basically I cannot reach the other side or the destination you're trying to contact. So the reason is because when this router gets the pings, it doesn't know what to do with it because it hasn't got in its routing table this network. So what we have to do now, we have to apply a static route on this router saying anything you receive from anybody, Anything you receive from anybody that you don't know what to do with it or where to send it, forward it to this IP address here. Basically, your last resort, it's this guy here, okay? And then we have to do the same on the branch router. We'll do exactly the same static route, saying to this router, anything you receive from anybody that you don't know what to do with it or where to send it to this guy, okay? So we're going to the headquarters, and then we do IP route. All zeros is the network and all zeros is the mask. Okay, any network with any kind of network mask, any network, any mask that you receive, basically anything you receive from anybody, send it to the 10.1.1.2, which is the other site. Okay, and we'll do the same here. IP route, anything to the 10.1.1.1. Okay, and let's go and ping from this guy now, ping the other side, which is the 192.168.1.1. okay, we ping, we lost one packet. If we go here now and we see show crypto ISACAM association, the association is active, the source is ourselves, and the destination is the headquarters. Okay, now that is the phase 1 association. Now if we go and have a look at the IPsec VPN, which is IC phase 2, and we type crypto IPsec show crypto IPsec SA. Here we go. This is that tunnel, and you see we had 4 packets encapsulated, 4 packets encrypted, and as I have said, we lost 1 packet. There are 5 packets there. We lost 1, so there's 4. If I ping again, but before I do that, let me show you something that you need to be aware of. This is what you need to see, the inbound and the outbound traffic. Okay, so you need to see the status active and active outbound. Okay, now we had 4 packets. I'm going to ping again, and we'll come back and have a look at how many packets. Okay, we've got another 5 packets there, so that number 4 should be now 9, because we have sent another 5 packets. Okay, and here we go, 9 packets encrypted, encapsulated, 9 packets encrypted, 9 packets decapsulated, and 9 packets de-encrypted. Okay, there is our tunnel, guys, boys and girls. It's all done, and let me show you how I created the aliases. Okay, you go into the configure. Basically, when I'm here at this prompt, this is my execution prompt, exec prompt. Okay, if I type config T, now I have entered the configuration prompt, and the commands I've done from here. So I need to create an alias where when I am at the execution prompt, basically I am here, okay, execution prompt, and I type C, that means config T. Okay, when I'm at the execution prompt, basically here again, and I execution prompt and I type SR, it means show run or running configuration. Okay, when I am at the execution prompt and I type SI, it means show IP interface brief. Okay, and then we have to move to the configuration prompt now. Alias, when I am at the configure, when I'm at the configuration prompt, basically where I am when I am here, if you remember, we cannot type show IP interface brief. We have to type do show IP interface brief. So when I'm there and I do E, first of all, it means end. And when I am there again at the configure prompt and I type SR, it means do show run or running configuration. And when I am there again at the configure prompt and I type SI, it means do show IP interface brief. Okay, that's how you create aliases. So if I type SI now, it will give me the interfaces. If I type SR, show run, it will give me the running configuration. And if I type what else did we do? Show run, show interfaces, and end. If I type E, we'll end it. If I type C, we'll enter the configuration. If I type E, we get back again. If I type SR, I just get to the show run. And if I type SI, show interfaces, and so forth. Okay, so that's how you create aliases. And I think that's all there is to it, guys. Thank you ever so much for watching. If you need anything or any tutorials on any subject, please leave some comments and I will come back to you. I thank you very much for watching again, and you have a nice one. Bye bye.